Hello everyone, good to see you again. I call myself Mr. U.S. Patil, working as assistant professor at Sharad Institute of Technology, College of Engineering at Rao, Chalkarzi, which is at Kolhapur district, Maharashtra. Today in this video, we'll go through the part robot programming. So let's get started with the robot programming or programming the robot. There are various methods by which robot can be programmed to perform a given work cycle. Uh, Here we divide these programming methods in some categories. There are four categories or five categories are there. So here you can see there are manual setup, walkthrough method, lead through programming, and offline programming, and last one is robotic programming language. So here in manual setup, or you can say manual method, in this method is not really programming in the conventional sense. uh, it is more like setting up a machine rather than the programming. So it is a it is a procedure used for a simpler robots and involves setting mechanical stops or cams, switches, or you can say relays in the robot's control unit. For these low technology robots used for short work cycles, for example, you can say pick and place operations, like that kind of operations, the manual methods or a manual setup programming is used. And the manual program method is where adequate, very uh, short work cycle will be there, it would be applicable. And another is walk through method. In this method, the programmer manually moves the robots and arms and hand through the motion sequence the work cycle. Here each movement is recorded into memory for subsequent playback during production, and the speed with which the movements are performed can usually be controlled independently so that the programmer does not have to worry about the cycle time during the walkthrough. The main concern is getting the position sequence correct. The walkthrough method would be appropriate for spray painting and arc welding robots. This one is. And next one is lead through method. Uh, this lead through method makes use of a teach pendant to power drive the robot through its motion sequences. The teach pendant is usually a small handheld device with switches and dials to control the robot's physical movements. It's kind of a TV remote control, like that, gaming remote, that's that kind of. And each motion is recorded into memory for future payback during the work cycle. If you want to same work to later, it would be get recorded, and again it would uh, play the same role as previous. And the lead through method is very popular among robot programming method because of its ease and convenience, where it's lead through programming. And another method is that offline programming. That is offline programming. Here This method in this method involves the preparation of the robot program offline in a in a manner similar to numerical control part programming. Offline robot programming is a typical accomplished on the computer terminal. After the program has been prepared, it is entered into the robot memory for use during the work cycle. The advantage of offline robot programming is that production time of the robot is not lost to delay in the teaching the robot a new task. Programming offline can be done while the robot is still in the production on the preceding job. This means higher utilization of the robot and the equipment with which it operates. Another benefit you can say associated with that offline programming is the prospect of integrating the robot into the factory CAD/CAM database and information system. In future manufacturing system, robot programming will be performed by advanced CAD/CAM system, and just as numerical control part programming or programs can be gener- generated by today's CAD/CAM technology. And another is here robot programming languages. Here there are two program languages we can say. One uh, you can say the non-computer controlled robot do not require a program language. They are programmed by the walkthrough or lead through method, while the simple robots are programmed by manual methods. Which the introduction of computer control for robots came the opportunity and the need to develop a computer oriented robot programming language. Here we'll discuss two of these languages. One is VAL language and another is their MCL language. So here VAL language developed for the Unimation or Puma robots, and MCL and APT language developed by the McDonnell Douglas Corporation. So here if you see here VAL language, it was developed by Skemman Victor Skemman for the Puma robot, an assembly robot product produced by Unimation. Hence, VAL stands for Vector's Assembly Language. It is basically an offline language with which the program defining the motion sequence can be developed offline. But the various point location used in the work cycles are most conveniently defined by lead through. So here VAL statements are divided into two categories. One is monitor commands and the programming instructions. The monitor commands are set of administrative instructions that directs the operation of robot system, and the monitor commands would be used for such functions as you can say preparing the system for user to write programming for Puma, and defining the points in a space, commanding the Puma to execute a programming, listening programs on the CRT. Some of the important monitor commands are given in here, some here tables, together with a description of the commands and one or more examples showing how to it would be entered. The program instructions are a set of statements used to write robot programs in VL direct the sequence of motions of Puma. One statement usually corresponds to one movement of robot's arm or twist or we can say wrist. Examples of program instructions includes move to point, move to a point in a straight line motion, or open gripper or close gripper, such kind of. If you see here, edit, this statements abbreviated that ed is used to create or modify the program named in the statement. For example, edit test or ed term, like that, right? So executive, this is used to command for the robot execute the program names. The statement can be abbreviated ex, right? Ex, the user can be specify how many times of the program is to be executed by the given number of execution following of the program names. For example, ex test, ex test dot 5 1 2 3 4 5, like that. And speed is this command abbreviated that sp, they specify the speed of all subsequent robot motions under the program control. This command would proceed the execute command. For example, speed is 50 if sp 50 or 30. Here is another command language, or you can say this statement would be used to define the correct position of the mode robot by a symbol specified by the user. Example, here a or here pt at point 1, like that. The user would move the robot to the desired position under manual control by mean of the teach pendant. When the robot is in desired location and the user defines that position with here statement, sorry, some data is missing here, and the user defines the position with the HERE, this statement, and the CRT displays the Puma 6 axis position, and the user then depresses the carriage return button to the proceed. And another here, if you see here, in this the program instructions are entered into memory to form program by first using monitor command edit, as we discussed, so on. So if you see MCL language, MCL stands for machine control language, and was and was developed by McDonnell Douglas Corporation under contract to the US Air Force ICAM. This language is based on the APT or numerical control language, but is designed to control a complete manufacturing cell, including a cell with the robots. MCL is an enhancement of APT which processes additional options and features needed to do offline programming of a robotic work cell. Additional vocabulary words were developed to provide the supplementary capabilities intended to be covered by the MCL language. These capability includes vision, inspection, and control of the signal and form and from the various devices that constitute the robot workstation. A list of some of these vocabularies were presented. You can see here. This is also example of VAL, not for this MCL. Here these are the representative of even VAL language, even VAL language that moves, approximate, as, depart, open and close, exit. So this is another some of the representation word of our VAL language. And we are seeing about that MCL language. These are the some programming words in MCL, that device, that this command is used to activate device in the work cell. And send, this word causes an output signal to the send to the defined destination. And receive, RECEIV, similar to send, but this word causes an input signal to be accepted from some defined source. WORKPT, this statement is used to define the sophisticated tooltip, that is work point. And ABORT, this word is used to half or halt all tasks activity, halt all the task activity. And this task is, this word allows the program to define the certain portion of the program as tasks, which can then be controlled into execution either singly or in combination with other tasks. REGION, this statement is used to define the closed two-dimensional path for vision processing. And locate, LOCATE, the LOCATE command is used with an vision system to seek out and identify a specified part within the field or a view, and to determine the position and orientation of the part. And this is what the part programming language, where there are two, one is VAL and this one is MCL language. And come to the part of next is robot cell design. Here in robot cell design, the robots generally work in with the other equipments. These equipments may be conveyors, fixture tools, and machining tools. The robot and associated equipment form the work cell. The robot work cell can be organized into various layouts, and these are the some classified robot cell design. That is, first is robot centered cell, second is inline robot cell, and third one is mobile robot cell. If you see the robot centered cell, this is what representation of robot centered cell. Here in this, the robot is positioned at the center of the cell and associated with equipment arranged with the around the robots. Here it shows a robot centered work cell layout and the robot programmed to serve several machines. Other example includes die casting, arc welding, plastic molding, and similar product operations. This is what a robot centered cell. And if you're talking about inline robot cell, inline robot cell, next one. This is what inline robot cell. Here in the inline robot cells arrangement, the robot is located along the robot is located along the moving conveyor and performs the tasks on the product as it travels part on the conveyor, right? This most commonly example is the car body assembly, where robots are located along the assembly line to spot weld the car body frames and panels. Here some, this is what a figure of that inline robot cell. And third one is this mobile robot cell. Third one is, this is mobile robot cell. Here in this element, the robot is mounted on the mobile base, right? Mobile base. The mobile bases used in robot cell are tracks fastened to the floor or overhanged rail systems. The robot is moved to various equipments within the work cell. Right? And this figure illustrates the mobile robot cell in which the robot is mounted on the carriage. And this is what another classify of robot cell design. So in the next video we'll see the advantage, or sorry, application or characteristics of industrial robot applications and all. Thank you one and all.